So you should have titled your next blank page, Calculating Net Force. Right now, just put your pencil down for a moment. If you need to catch up, remember, just raise your hand. Your teacher can pause the video. So first, I want to look at what I've typed on this page where it says opposing forces. The first scenario we're going to look at is when forces are working against each other. In that case, if you're trying to calculate the force, you subtract them. Pause for just a moment and copy down what I wrote here into your notebook. Notice that I put opposing forces, that's like your vocabulary word or phrase, in capital letters. You could underline yours, you could box yours in, but make it stick out somehow. Okay, you should have been able to copy down the definition of opposing forces. Again, just raise your hand if you need to pause the video. Now put your pencils down and let's look at the examples I have on the left. In our first example of opposing forces, we have a force of 5N, which means 5 newtons. Newtons is the unit we use for forces most of the time. Sometimes we use pounds, but it's named after Isaac Newton. So we have 5 newtons of force pushing the box this direction. And then on the other side, we have 3 newtons of force pushing the box in the opposite direction. So since these are opposing forces, we would find the difference between them. So we subtract 5 minus 3 and we get a difference of 2. That means our total force, or our net force, is 2 newtons. The last thing I need to do is, in my answer, is show what direction the box is going to end up sliding. And it's going to end up sliding where the bigger force was, right? 5 newtons was bigger than 3 newtons. So the box is going to end up sliding the direction that the bigger number was pushing it or pulling it. Okay? For the second example, we've got, again, 2 opposing forces, but this time they're equal. They're both 5 newtons. I would still subtract and find the difference. 5 minus 5 is 0. So that means my net force is going to be 0 newtons. And in this case, the forces ended up canceling each other out, which is what we call balanced forces. So it's a total of 0 newtons. I don't need to show an arrow of the direction the box is going to slide, because the box would not move. The forces are canceling each other out. There's no movement. The forces are in balance. Right now, your pencil should be on your desk, sitting there not moving. That means it's in balance. Any forces that are acting on it are balancing each other out. And there are forces acting on it, like gravity, air pressure, etc. But they're all in balance, so there's no movement. Whenever the forces are not balanced, that's when you get movement. So pause the video for a moment and please copy down the 2 examples of opposing forces into your notebook. Okay, you should have had time to copy down the 2 examples of opposing forces into your notebook. And the last scenario we're going to look at would be forces can also work together in the same direction. And in this case, you would add the forces together. So let me show you this first, and then you can copy everything down. So when forces work together, let's look at our example on the right. We have 5 newtons of force pushing the box this way, and then 3 newtons of force pulling the box in the same direction. So these 2 forces are working together. It'd be kind of like if one person was pushing a piano and the other person was pulling it and they're trying to move it together. So whenever your forces are working in the same direction, you add them together. So we would do 5 plus 3 equals 8, and our net force, our total force, is going to be 8 newtons. And then, of course, the box is going to slide the direction that they were both pushing and pulling. So don't forget that arrow to show the direction the box would slide. All right, so pause the video now and you guys can copy down the definitions and examples. Really miss you guys.